All right, so the next thing, we did our operations. Now we're going to look back here at the composition of functions. Now a composition of functions is where you're subbing one function into the other. So that's what composite, right? You're subbing one in for the other, and the notation looks like this: g of f of x, or you can write the notation like this, like g, and then as an inside function, you have this f of x. So that's the point here, is f of x is the inside. You take x, pump it through your f of x function, then whatever you get from that is what you run through g of x. So it's just like subbing in functions. That's happening, right? So there it is. So let's look here at example 9. We're going to let f of x equal 2x minus 1 and g of x equal 4 over x minus 1. So with that happening on these problems, then I can look at plugging one into the other. And it just makes an impact. Which one is going to come first? That's really the question that happens with your composition of functions, is you say, okay, which one comes first? And then how am I going to work that out? So part A here is f of g of 2. So when you have this value, you're going to take this 2, plug it into the g of x function, chunk that out. Whatever value you get out of that, that is what you plug into the f of x function. So I like to use this second notation because I find that it helps for me, because I'm so used to function notation, right, to work that out. So this is f of, and then I make my parentheses really big and plug that in. 4 over 2 minus 1, because that is my g of x function. My g of x function is what I'm plugging my x into first. So it's like a system, like a machine. You plug it into the first one, it does its thing. Then whatever you pump out goes into the next piece of it. So I'm really having f of 4, and then 2 minus 1 is 1, so it just leaves me with a 4. You do not plug 2 into the f. Do not. You plug whatever you get out of this into your f of x function. So now I have 2 times this 4 minus 1, because that is my f function. So really, f of g of 2, when I run it through the machine, is going to give me 7, right? Because 2 times 4 is 8 minus 1. I expect you to do that in your head. So then I get 7. The kicker to this, run it through the first cog first, right? Run it, whatever you're talking about first, run it through that one. Then whatever you get goes into your other one. So try this, g of f of negative 3. So the first thing I'm running negative 3 through is my f of x function. Whatever I get out of that goes into g. So g of 2 times negative 3 minus 1, because that's my f of x function. So I'm really taking g of, so you can see negative 6 minus 1 is going to be negative 7. That's what you plug in. So 4 over negative 7 minus 1 is that negative 1/2. Because it's 4 over negative 8. We know 4 over negative 8 is negative 1/2. All right, so that's what we're talking about here. F of negative 3 is that negative 1/2. All right. Very cool, very cool. You can do composition of functions, and it doesn't have to be a value, right? Just like with our adding, subtracting, you can do composition or add, subtract, multiply, and divide of just x. We're going to do a composition here of just that x. So here is example 10. I have f of x is equal to this 4x plus 1, and g of x is equal to 2x squared plus 5x. The first thing that we want to do here is I'm going to move this to this second page, actually. I'm going to cut it because I'm going to be jamming it down there. So it'd be better if we just had it all on this top page. Okay. Ooh, I love technology. Okay. So g of f of x. So the first thing I want to do is take my f of x function here and plug that into my g of x function. When that happens, you're going to sub it into every x that is in that g of x function. And then we're going to simplify. So this is going to be 2 times 4x plus 1 squared plus 5 times 4x plus 1. Now we multiply. When you multiply something that's squared like this, you can write it out as 4x plus 1 times 4x plus 1. I would really like it if we start upping our game a little bit here and taking care of some of that I don't know, FOIL type algebra and coming up with our shortcuts. So we can square this first term to give us 16x squared. Multiply these together by 2 to get an 8x, and then square that last term. Over here, there's no big deal because you just distribute. Then I take this 2 and distribute it through there to get 32x squared plus a 16x plus 2. And now I have some like terms that we can work with. So we have 32x squared plus a 36x plus 7. That is g of f of x. If I take my f of x function, I sub it into my g of x function, then that is what I end up with. What if we go the other direction with it? I'm going to take g and sub it into x. I'm going to take f of g of x. Take my g of x function, sub that into my f of x function. So here it's nice, I only have one sub in. So I'm taking my g of x function, subbing that into my f of x function. And then you just simplify. 8x squared plus 20x plus 1. That one was a lot easier, right? Because I didn't have two x's to sub in, or something squared. Now here's my question. Are these the same? No, right? Composition of functions is not commutative. Commutative means I could change the order. It matters. Is f first or is g first? That is going to make an impact. You got to watch out for that order. You do not end up with the same answer, and you don't even end up with the same amount of work sometimes, right? Right, so watch that notation. Watch that notation. You have to make sure when you're watching that notation that you're getting that set up. Okay, you can put functions together, or dun 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 dun, you can split them apart. Such as in example 11. I have h of x is equal to x squared minus 5 cubed minus 4 times x squared minus 5 plus 3. I want to split this up. Find the function f and g so that f of g of x is equal to h of x. So basically, instead of putting these together, I'm splitting them back up. Now, we've had super awesome work with factoring, so we'll be able to look at this hopefully a little bit more clearly. Do you see something in common here? Yeah, they both have these x squareds plus 5, right? So g of x is my input function. So that's where that has that common. That's going to be that input part. So if I'm going to determine what is f of x and what is g of x, in this instance, my g of x here is my input. So I want to say, okay, I am inputting this x squared plus 5 because that's what's in common. If I just look at that as, okay, now this is just a single value. This is just a single value because I input that in there. That is how you can determine what your f of x function is. So x cubed minus 4x plus 3. Do you see that? So this would be like taking this whole x squared plus 5 and plugging it into both of those x's in order to get this. Does that make sense? Yeah, so you're just seeing what's in common. So what is the composition is what it's called. So you can take those apart and you can look at them that way. I always like to look at these compositions because next semester in Calc 1, you are going to be looking at chain rule. And then this is a way that you're going to have to work in terms of your chain rule. All right? Cool. Just one more concept.